This is Computing Up, conversations about computation writ large, with Michael Littman and Dave Ackley. This episode was recorded July 11th, 2022.
Hey, it's another episode of Computing Up.
Are you sure?
That's what my calendar told me, and I basically am a slave to my calendar at this point.
Well, hey, Michael.
good to see you. How you doing?
Okay. You're starting your big new job.
Yeah, this is kind of the first real week for me at the National Science Foundation, and it's I'm not going to say anything bad.
That's a good idea.
The full weight of the federal government will come down on me.
Well, and it's too soon.
It's definitely too soon.
You got to clue up a little first.
We have a rule that was, I guess, more relevant when we had young kids in the house, but September doesn't count. That's the rule. We got it from our friend Sarah, because September is just like every year. Crazy things happen in September as you have sort of startup and new systems in place, kids starting in new schools.
Yeah, new classes, new everything.
Oh, it's like you want to panic and you want to say, this is never going to be okay. But like September doesn't count. So just like get through at the end of the month and then revisit. If something's still an issue, you probably should deal with it. But September is just crazy. This is September for me.
This is NSF September.
That's what the S in NSF stands for. So anyway, so that's a thing. So I'm in Virginia, and that's good. And traveled around a bit to conferences, which I hadn't done since the pandemic. And
how many times did you get COVID?
As far as I know, none. I think some people seem to just not be getting it, and maybe I'm one of those people so far.
No, yeah, sure.
But like everybody else in my family, has been visited by the COVID fairy. Yeah, I'm sorry.
Well, I mean, it just seems like everybody is out there. Everybody's going to conferences again. Everybody's just, like that. And I'm
the two conferences I went to, one was the Reinforcement Learning and Decision-Making Conference, which I helped organize and was in Providence. And so a couple of people got sick, but I think it was relatively well contained. Then I went to Korea for the Fairness, Accountability, Transparency Conference. And I think everybody got sick. And in fact, all the organizers got together for Korean karaoke at the end, and they all got COVID. This was like
excellent idea. Sure. Let's breathe very heavily in each other's faces.
Right. And spitting and whatnot. So, yeah.
Great.
But it was good to be back. It was kind of good to be back. And one of the things that I think went really well is that I got to introduce today's guest at the RLDM conference. And I was very excited because you may remember, Dave, you and I tried to write a book together a couple of years ago.
Yeah, I do.
Yeah, and it was the topic was, I think, going to try to be reinforcement learning, sort of computational reinforcement learning, but like thinking about what it suggests about human nature, how it is that people, get by in the world, process what we process, act like we act, feel like we feel. In what ways can a computing up sort of perspective shed light on that? And we thought we had a lot to say about it, but it turns out there's people who actually study this sort of thing. And and getting to introduce Oriel FeldmanHall and listening to her talk, which was fantastic, made me realize, maybe we could stand to learn a little bit more about how people think about these questions when they're studying actual people. I think we got some stuff right, but I think we were also a bit naive.
That's one of my features.
Right.
Relentlessly naive. Well, I'd be naive everywhere is the point, rather than
omni naivete.
De-naivetifying in one tiny little area.
Right, because that would be imbalanced somehow. Well, anyways, but let me welcome our guest. So, Oriel, thank you so much for agreeing to chat with us today.
Thank you for having me.
Sure. So okay, so help me out a little bit. So say a little bit about your background and your connection to, people and reinforcement learning.
I have no connection to reinforcement learning.
Oh, that's quick.
Okay,
easy.
Just to be clear, I did hear you give an invited talk at the Reinforcement Learning and Decision-Making Conference. So someone, somewhere, thought that what you had to say might be relevant. But okay, all right.
Well, we can talk more about that.
Okay.
And my connection to people is that I try to understand what motivates people as they interact with other people. So
the social part of being a people.
Yeah, the social part of being people. And that's why I think RL falls short.
Now
let's unpack some of that.
But we can talk about that.
Okay, so you're in the Brown University department called CLPS, which is Cognitive, Linguistic, and Psychological Sciences, and your degree is in psychology. Yes,
it's in neuroscience. Yeah,
neuroscience. Baboom.
Yeah.
Okay.
Yeah,
that sounds more, I don't know, meaty.
CLPS. So was that like 3 departments that got put together, or was that one? Wow.
And there's still trauma around it.
Yeah, that's a tough thing. That takes generations to get over.
Well, so this happened. So this is at Brown. I'm at Brown. Oriel's at Brown. But I think it happened before either of us was at Brown. Yeah. But so what I heard when I arrived is that there was a lot of dysfunction, and that this did somehow make things less dysfunctional, but that doesn't mean that it's non-dysfunctional.
It's only relative improvement.
There has been improvement, but maybe it's.
I heard this as well.
Okay. But then you joined the department.
and I am amazed at that possibility. Yeah.
I am amazed at that possibility that it could be more dysfunctional. No, I'm just kidding. I've heard every department is broken.
I think that's a fair bet.
It's just a degree of brokenness.
Yeah,
and I would want to blame that. What is that thing you said before about people being social with each other? I blame that more than anything.
I blame the lack of that. The lack of people wanting to be good citizens.
Well, okay, so I'm sure we're going to drill into this, but, in looking at some of your papers, which all had these unbelievable titles that I'd say, no, you have to explain more. I saw the phrase social RL frameworks. That was on a paper with your name on it, had that sentence in it in the computational challenge of social learning paper, like that. So,
that's what one of my papers' title has reinforcement learning in it?
Not in the title, but in the text, talking about social RL frameworks.
But that's where I poo-poo RL.
Okay, all right, that's true. That wasn't a sentence that was dumping on the RL part of things. But I took it to mean, hey, there's social RL.
There is social RL.
Okay, but what you're saying is there should be more of it. We should recognize its differences from traditional reinforcement learning, as reinforcement learning dweebs like Michael tend to think about it. Is that what you're saying?
I think so we're going to jump right into the deep end. Let's do it. So are we going here right now?
Sure, let's do it.
But just to ease us down the steps into the water is to just define a couple of these concepts. So when you say reinforcement learning, what do you mean? Because I think I always tell people that reinforcement learning as a phrase was originated in psychology. It was picked up in computer science with a misunderstanding and then applied in a way that was different. And in many cases, it's now being re-imported into psychology with the computer science definition. But some people in psychology still kind of hold to an older notion of reinforcers, which is the thing.
The old notion of reinforcement learning, like as in 70 to 100 years ago, I completely agree with. I mean, I believe that they're reinforcers. So it would be hard to argue against a concept like there are reinforcement schedules. Some work more effectively than others for learning and stuff like that. That's not what I'm talking about. I'm talking about the second thing you just said, where you get a reinvigoration that comes through the lens of CS, of computer science, and people borrowing it, having a lot of jazz hands around it because they're using fancy methods borrowed from a field they don't fully understand, applying it to data that doesn't make sense and calling it a day and trying to get into a high impact paper.
Okay. All right. And so in particular, the thing that I think of as being the one unmitigated success of the field of computational reinforcement learning, which is that we convinced the psychologists that we were right. That's a huge mistake. And we should never have admitted that this has happened.
Well, hold on a second. Who listens to this podcast?
I don't know.
It is a big mystery. It seems like it's mostly random folks, plus Michael's ex-students.
So it's mostly CS people.
I don't know. We just got an email a couple of weeks ago from somebody who works in the insurance industry, and they somehow
that apparently my audio was missing from the
that was my I had screwed up a thing. That's why he actually sent an email. But I was really thrilled to get it
somebody
because
listened.
Exactly. And so anyway, so Michael says, our audience is like, I say it's this rounding error, but Michael says, it's like bigger than a lecture, but smaller than a keynote, something like that. And that's what it is. And so,
Elena listens, right? Dave's wife.
Yes. My wife also listens. That's right. So, I mean,
But
whatever you feel comfortable with, is as far as you should go.
I just want to know who's going to be annoyed or angered by the things that I'm saying.
Yeah, at the moment, it's like the people in the rounding error. So screw it.
Okay.
And if you seemed fine with it at the RLDM conference, you definitely were out to ruffle feathers there. So go for it.
Go for it. Yeah.
I didn't even think that was that incendiary. I thought I was just trying to get a little conversation going.
Excellent. So now we know
just
we're
asking questions.
Anyway, okay. So Michael, did you get our dipping in the shallow end yet, or are we still trying to do that? So we're agreeing that it's not the old-fashioned Pavlov's dogs reinforcement that we're talking about. We're talking about computer science, someone that came up with a goddamn scalar that's either positive or negative or zero, and that's all you need to know, and here we go with our learning. And we're taking that into psychology somehow, and okay.
Right. So let me ask you this. Let me turn the question for a second. Do you think that people, I know you guys are CS, but do you, and computers learn that way because it's easy and it's zeros and ones and whatever.
Right.
Do you think that people actually learn in that way? Like, do you think that a computer, let me ask two questions. Is a computer analogous to the brain? And do you think that the brain actually learns about the world with that kind of algorithm?
I mean, I think it's analogous because you can torture an analogy to death and have some tiny little remaining bit. I mean, brains and computers are both computational systems, so they are analogous at that level. But once you start drilling into it, where the typical computer is deterministic, everything is centralized, memory is completely passive, all of that stuff seems like brain, no, like that. So that's number one. And number two, the thing that, does the brain use reinforcement learning, or do minds use reinforcement, at some hyperspace, super far away level? The answer has to be yes, because it's adaptive and it tends to go towards good things more than bad things, so at that level, yes. But at the level of saying, do we believe the brain computes a scalar, that someplace in the brain there is a little brain activity that goes from +10 to -10 or whatever, and then that gets distributed all the way back to the rest of the learning system? That seems to me completely ridiculous. And the idea of developing a scalar is this incredibly lame abstraction that reinforcement learning people in computer science did because it's the simplest case, like that. Whereas I think, the brain has got zillions of little sub-reinforcements and some that are conflicting with each other and all that. And there is no absolute central number that the brain ever develops except post hoc, except if someone makes it up. Does that make any resonance?
Yeah, I hear you.
Yeah. I mean, does that go with the directions you go, or is that heading more in the wrong direction?
I guess I should say that I'm not sure. So look, I don't study reinforcement. I mean, I don't study reinforcement learning like you guys do. And so sure. The best way I could say is like, I fake it till I make it. So I borrow principles from, lots of different domains. I think sometimes, psychologists use them because they're easy frameworks and they're easy to implement, and it makes things easier to study in a really complex system. And if we're trying to distill things down to like Oxen's razor, the simpler the framework, the better it is, kind of thing. Right. And I think that's really useful. I think people are attached to that. So like, do you guys know the whole dual systems, system one, system two analogy in human psychology? That's another one that has been widely adopted over decades and decades. I think it's a massive oversimplification of how humans work and how the brain works. But it's really easy to test. It's really easy to talk about. It's really easy to put nice little paradigms together and say, oh, look, we have evidence of this and this and this. It's a lot harder to say, oh, well, our neat little idea of how the brain works doesn't actually fit this way, because like we could do far more complex experiments that, you know, break beyond the confines of what we think is system one, system two. It becomes sort of like, in some ways, like a self-fulfilling prophecy. And then books are written about it that are like bestsellers, like Thinking Fast and Slow. So, you know, I think that I don't know the answer to the question I asked. I guess my worry and my gut, which isn't very much because it's not principled, is that, you know, RL provides a neat framework to fit things into. I think reward is often the catch-all. And I think that the way that reward has been reused mostly from CS space, I think is problematic for how humans, the complexity in which humans are able to learn. And I think the best evidence for that being the case is the fact that computers fail massively when it comes to the complexity of what humans can do. So sure, a computer can outwit like a human when it comes to chess or AlphaGo or something with really bounded conditions and decision trees that are limited to, let's say, the millions or whatever it is. But if you change the context or you change the irony or you change something about the system, humans adapt with an inordinate amount of speed and flexibility that computers don't have.
Right. I mean, that certainly sounds right to me. It's certainly, I feel like, well, put it this way, in a really big picture, one of the stories of science and technology is that science tries to come up with these descriptions that are useful in some way, that categorize stuff into ways that you can make predictions A and B and so forth. But then engineering takes those descriptive frameworks and turns them into implementation frameworks to say, I'm going to build a machine along these principles of system one, system two, say. And then they're actually going to build and say, this is system two. Look, there's the system two controller. When, for my money, you know, the system two was much more emergent. It was much more a consequence of actual physical decisions that were made by evolution, by whatever, by developmental evo-devo stuff, like that. And it was never actually implemented directly. But that's what we do. We make up this language, whatever it's going to be, reinforcement learning, we're all greedy, or we're all, selfless, whatever it happens to be. And then we turn it around and we make it prescriptive. We make that everything has got to fit into one box or the other there. And that is always wrong. But what other game do we have to play? And so it's kind of like, I think of it in terms of programming, in terms of software engineering, that when you make an API, you make an application program interface, that's a bunch of decisions about how you're going to represent. And we got a bank, we got a customer, we got balance, we got transactions, all of that stuff that you make up. That's how you're then going to see the world. And that's exactly what we do as well, whether we choose to make it system one, system two, or whatever it happens to be, or for the greater glory of God, or whatever it is. And the thing that blows my mind is it's got this thing like love and money that if people believe it, maybe it kind of becomes true. Because they're actually reconfiguring their brain to organize things. Oh, now I'm seeing that as a system one thing. Oh, now I'm seeing it as a system two thing. And that changes their behavior, changes how they categorize the world that they see. So, I wonder, is it possible that psychologists, say, who are building experiments and they say, let's simplify this to the stag hunt versus the dictator takes nothing, or whatever it is, that in fact, they're engaging in this API construction as well. They're building ways of thinking about stuff that can make itself come true. Does it sound completely crazy?
You're saying it's a self-fulfilling prophecy.
So, which is exactly what you already said. I just took a lot longer to do it, I guess. You think?
I think that's true for those who have more metacognition about it. So for, let's say, like academics, I think that's certainly true for academics or people even that perhaps dabble, in these sort of like pop sci books that everyone's putting out these days. But
sure. Like Michael.
What's your book?
I don't know anymore.
Come on, the title. The title.
It's Code Dependent No More: How We Tell Machines What to Do and Why Everyone Should Learn.
Okay, well that's not too bad.
Why everyone should learn.
That sounds judgy, doesn't it?
We're here for the judgy titles.
All right, that's fair.
So okay, so
I wanted to comment because the one thing that Dave said that resonated with me, the one thing that most of it just went right by, but the one thing that landed is this result that says basically, if you are an economist and you study greedy behavior, then if we put you in one of these experiments, you're much more likely to be greedy, right? The economists kind of act like economists say people act. And that maybe is an example of this little bit of a self-fulfilling loop.
Right. That could be.
I don't know if there's other examples. It would be hard for me to believe that if you just kind of, you read a psychological account of how memory is organized and so forth, that you actually reorganize your memory to be that way. Because I suspect most of these accounts are simplistic enough that if you actually acted that way, you would be unable to function.
Maybe. I mean, but if you make a change as simple as who you consider in group versus who you consider out group, then your behavior changes dramatically to anybody who moves between those two groups. And if you describe things differently, that will lead to different judgments of in group and out group, and that will lead to very different behavior. So, I mean, that seems like an example of the self-fulfillingness that's bam. I mean, it's pretty damn salient for how things are going to work out behaviorally. Okay. All right. Well, but Oriel, I still feel like I don't understand exactly. I haven't let you talk, so I don't understand exactly where it all comes from, what your take looks like. So can I possibly shut up and you can let me know how this all makes sense?
So I guess my take, to put it perhaps differently, my take is that, I guess it comes more from a worry rather than a take. And my worry is I think either two or threefold. Let me see. The first worry is that there are people in my field that I think borrow methods without fully understanding them and what they really mean, and use them in ways that are meant to be good, right? So one of the problems in psychology, certainly social psychology, is with fuzzy theories, right? And so if you don't define something, there's going to be this continual search to either prove or disprove something. And it's really hard to get to that space of proving something to be right or proving something to wrong, especially if you care about mechanism, if you can't define things in really concrete, let's say, computational terms.
Right.
And so the motivation and the intent is a good one, right? You want to borrow methods that help you define things better, to understand how the mind and the brain works. But the problem is that when you use an oversimplified framework, which I think that RL, in many cases, especially for the social world, I think it does work. There are cases where it works very well, it's very clean, it's very elegant. I don't think it always successfully mirrors complexities of the social world. So if you think what's happening in the social world, so the listeners cannot see our faces; they're just going to be hearing us speak. But there's intonation with everything that we say, right? So whether I'm posing a question depends on how I say it and what syllables I end up pronouncing more or less. If they could see our faces, they could also see when we nod to one another, or when we smile in agreement when someone's saying something, or whatever it might be, hand gestures, etc. So all these things. And those things are also like very much simplified versions of, how people interact. It's just like one facet of the interaction of like, what's Dave thinking right now? He sort of has a flat face. I have no idea. Like, oh my God, would Oriel shut up or get to the next question? She's been talking and talking. Like, who knows? You know what I mean? So there's all of these, like, there's all these spaces that are unbounded in ways that when you're dealing with something that's like an object in the world, like picking up a coffee cup or opening a window or waiting for, the C train in New York, you know that it's going to happen with a certain probability. You don't have to worry about what the cup thinks or whether the C train, maybe the C train's not a good example, but like there are many things in the world that you have, better estimates of, and you can work with in a more tangible, concrete way. And human beings are not like that. And every human being is different. And so, of course, there's norms and we can distill things, and there's like latent structure because we have, norms and cultures that help make the problem easier. But at the end of the day, it's a far more complex problem than the things that we often deal with when it doesn't involve other people. And that's where my second worry comes in, which is that RL becomes an oversimplification for fully understanding how people interact and learn about one another, which I would call like social value. So like social value is like, Dave, what are you like? Are you going to be someone that I can trust? Are you going to be someone that I can communicate? Are you going to be someone that I'm going to have a good, jovial conversation with? Same thing for Michael, all these things. How do I learn about that social value in these highly complex spaces? Can RL really capture that?
Right. Okay. So I hear, one of the things I hear is that, okay, so we should give up on science. We should give up on psychology.
That's even fair.
Well, to take it to the limit, I absolutely agree that the real world surrounding me, say, and all the stimulus I'm getting and so on and so forth, and my reactions is this nonlinear combination of everything that's going on around me. And yes, it has some relatively lower order features to it, the norms you talk about and so on. You could make certain predictions about things I would do and not do, but you certainly could not make very many predictions about what sound I was just about to make, that kind of thing. But when we're playing this game of science, when we're playing this game of trying to say, is there some norm that is, reliable enough that it's worth studying, trying to find the corners of, so that we can, understand ourselves better, predict ourselves better as a species, as individuals in a population. Then again, it's the only game in town. So we're going to overstate, we're going to oversimplify, and it's either say, let's be a little humble about our claims, which maybe the pop science books tend to miss, or certainly the headline writers and the publicists tend to miss. But maybe we just have to say, yeah, guilty. But maybe within we're all sinners. There might still be distinctions to make.
So I feel like that you're going too far in the other direction.
Okay, great.
So I don't think that's what I'm proposing at all. I think that, and I don't even think it has to do with a sense of humbleness or anything like that. To me, it's more of a nod of where can it help and where does it not? And acknowledging the spaces in which it does provide an elegant framework, but also acknowledging the spaces where it does know we need more, rather than sort of, having like the full, like, I love RL, I can answer everything kind of mentality, which I see a lot of. I mean, I see a lot of people do it, like, sort of blindly adopting it because it provides a lot of usefulness and there's a lot of tractability. And I just think that we should be more careful in our applications.
I mean, is this a version of sort of the fundamental attribution error that it's like, our positions are always nuanced, but their positions are always categorical?
I would actually say, look, I mean, again, I don't live in the world of CS, but I would say it's a safer bet to use RL in the CS world. I don't see that as problematic because you guys don't deal with the issues that we deal with. I would say we're the ones that fall here. So I'm not pointing fingers at you guys. I'm pointing fingers at my team, my in-group. And I guess I also just want there to be a more, I don't know what the right word is. I don't know if it's to say like a more philosophical science or I mean, this is getting into like the problem with science right now, which is like turning out big, high impact papers and who can make, do the fastest work and, publish it in the biggest, journals possible and all that stuff. And I think what I think is more interesting is being able to show some sort of mechanism that has lasting power, even if it doesn't like subscribe to the canonical framework that we think it ought to subscribe to.
Yeah. Well, I mean, there's this is the thing that Michael and I have talked about over decades about, science being this search for the greater truth versus science being a job. And there are these two interpretations that have to run down the field together, well, one way or another, but they have different imperatives. And so, I hear you that we need to have everybody, let's rootin' for science be the search for greater truth and let the impact go hang.
And I say that, being totally guilty of everything I just did as well, but
Sure.
but I also I guess the thing is that one of the difficulties with the thing that I just offered up is that it's in the modeling world, it's a bit of a Wild West. So if you don't, how do I say this? Like you can choose to model what you want, and you can choose to, in some ways, almost find what you hope to find by putting the right model in place.
Right.
Or you could spend a decade testing every model with every bell and whistle and getting effectively nowhere. And so there's this like judgment aspect that people don't talk about very much, or I don't feel like they talk about. And that seems like sort of a lost opportunity in our training models.
Yeah, absolutely. Well, so I believe we are all boxists here in Michael's term. Michael calls himself a radical boxist in the George Box sense. All models are wrong, but some models are helpful, useful. Yeah. And it sounds like that's what you're saying in part as well. I mean, if I can shift gears a little bit, because I really want to ask you about a couple of your papers before we use up all of our time. So in particular, empathic concern drives costly altruism. And as I understood that paper from looking at it, it was like, there are some people who say, oh, you're just empathetic because it makes you feel good. Like you don't actually give a crap about helping other people. You just want to make yourself feel better. Like that. And what I read this paper of yours as saying is that, well, no, actually, we can gather evidence, oh my God, that distinguishes you making yourself feel good from you trying to actually feel empathetic concern for others and whatever it is. And I got the impression that you were actually putting people in the magnet tube somehow so that you were measuring their brains, and that was how they were going to tell. Could you unpack that a little bit? How do you tell the difference between empathic concern and just making myself feel better?
Sure. So it's a amalgamation of a bunch of different tools. So some are very simple, right? We basically give people questionnaires. We ask them a whole host of questions in which we assess, unlike essentially paper or pen or through a computer, what their empathic concern is. So we use these like essentially well-vetted questionnaires that are meant to give us an empathic concern score. Okay,
can you unpack the term a little bit? So empathic concern, meaning like it matters to me whether you're okay. Is that?
Yeah, well, we're getting into fuzzy.
Well, but just
fuzzy psychology, and I'll tell you why.
Just a rule. Okay.
There's been a debate in the field for 30 years about what is empathy, and there's no definition that people will settle on of what they agree empathy is. Is it sympathy? Is it compassion? Do you have to feel the pain of others? Do you not have to feel the pain of others? Is it that you have conscious awareness that someone else is in pain without feeling their pain and therefore are willing to help? I mean, there's a lot of different ideas about what is empathy. So giving you a definition would be difficult. The best that I can do is to say that empathy is fractionated into different dimensions or components. There's a cognitive component, and there's affective component. Affective meaning like emotional component. Empathic concern falls into the emotional side. So it's more akin to not necessarily I need to feel your pain, but I need to experience the fact that you are in need, and therefore, well, wanting to do something about it is where you get the altruism, part of it. But it's believe that the empathic concern stimulates that motivation.
Okay.
So we ask people using questionnaires to, make decisions of, or rate how, can they empathize, for example, with people in movies, with characters in movies, when they read books, stuff like that. When they see someone, experiencing pain, how do they feel? It's like that kind of stuff. So we get these questionnaires, everybody gets a score that tells us how empathic they are. Then we put people in the scanner, in the big magnet tube, as you say, and we look at what happens in their brain when they make different types of decisions. So in this particular task, we call it the pain versus gain task. There's two people. So let's say it's Michael and Dave, and I'm going to give Michael a bunch of money. And I'm going to say, if you want to keep this money, you have to apply electric shocks to Dave. And on every single trial, you can decide whether you want to give up your money to prevent these electric shocks from being administered to Dave, and you get to see the electric shocks being administered to him. So you get to see everything happening.
Wow.
And this is all happening while you're lying in the scanner. So you make your decisions time after time, and then I tell you, okay, well, at the end of the task, just so you know, whatever money's remaining in your bank, we'll multiply it up to 10 times. So you could walk away with, quite a bit of money. And then we record the brain activity that's happening. And what we do in the analysis pipeline, to make it overly simplified, is we take people's empathic concern scores, and we see how that factor modulates the brain activity given Michael's decisions to apply electric shocks to Dave.
I see. So you have up front some score of how empathically concerned subject A is versus subject B, and then you look at the A's brain and B's brain when they're doing this torture Dave thing, and that would perhaps identify portions of the brain that are identified more with being a jerk versus being nice, something like that.
So in this case, what we were looking at, to answer the question that you originally started with, was what parts of the brain are being lit up when empathic concern is modulating Michael giving up more money to preserve your welfare, Dave. And what we find is that regions having to do with pleasure and reward. So despite the fact that Michael's giving up money, so he's giving up, $10, $20, $100, whatever it might be, even though he's giving up money, the reward and quote unquote pleasure part of the brain is being more activated in his brain than someone who has low empathic concern and is keeping a lot of money and making a lot of money at your expense.
So does that support Michael's doing it because it makes him feel good?
Kind of.
Okay.
That's the opposite of what I thought you were saying, Dave.
Yeah, exactly. Me too. Did I get the paper backwards?
Well, I think it's, a lot of people try to distill the whole, empathy for altruism down to the fact that, are we really altruistic if we get, some hedonic pleasure reward out of the process? I don't think that's a useful question to ask. Who cares? If we're good to other people and we get pleasure out of doing it, so be it. Let that be the case. Let that be motivated. There has to be, intrinsic motivation to do the things that we want to do in the world. And if it makes us feel good to help other people, to give up our own money, there shouldn't be any harm in the idea of pure, not having pure altruism. But yes, what it does show, look, the work is a little bit, I would say, reverse inferency, which, do you know what that is?
No, I don't.
I heard reverse inferency, which is sort of that you don't have direct evidence, but you can kind of back into it from first principles.
I see.
So like the fact that we saw that, the caudate and the ventral and the VTA, which are like two
pieces of the brain.
Two pieces of the brain that are classically associated with reward and hedonic pleasure. That's why we're making the assumption that we're making about what I said, like it feels good to help another person if you're high in empathy. But we don't have direct evidence. That's a reverse inference. It's a reverse inference to say, to look at the brain data and say, well, because we got caudate and VTA activity, you're seeing X, Y, Z. So I caution the finding a little bit.
Well, but that's it. And it's also the same sort of thing about then turning it around and making it prescriptive, taking an observation thing and saying, okay, let's say this is the way it is. So now I'm going to build robots that are going to have that built into their code, and they're going to do it. They're not going to have any frickin' choice because that's going to be part of their physics. Okay, all right. Well, so did I hear you suggesting that the jerks that were just going for the money didn't actually have that much pleasure? They weren't sitting there thinking, I'm King Midas, 100 pounds. It's so great. I feel wonderful for having so much money. There was less of that?
Correct.
Oh, that's interesting.
But some, right? So, and I guess did they help people? Did they shock Dave? And if so, they got money for it.
Correct.
But less.
Except they didn't really shock Dave because everybody knows Dave, and this was an unknown Confederate, right? That you were actually doing.
They meet the guy.
Right. Okay. But it's a new. It's not like.
It's not your friend.
But this is very Milgram-y, right? There's that Milgram experiment.
Well, Simpsons episode, yeah.
Okay, that's one way to learn.
Yeah.
Went way back to the source.
That's right. That's the touchstone for people. Well, but hey, all right. Well, thank you for explaining that to me. And you've done all this great stuff. You've done all this really interesting stuff, like scaring people with spiders and shit like that. Like that.
I was just a pawn in that experiment.
Okay, all right. I know that was one of the older ones, but there it is. It pops up on Google Scholar, like that. So you've had some criticism for your own compatriots, colleagues to a degree. What do you feel good about in terms of new directions, new stuff that we can learn? That might make a difference. Do you have any hope for which way to go, or just which way are you excited about going?
I hate that question.
Oh.
Well, we could replace it with another one.
Pass.
Okay, so I mean that means you feel a little bit glum. I mean maybe it's time to switch fields.
I'm not glum at all. I just think that it's I don't know how to say this without sounding kind of like a chump. I just like what gets me excited is being able to sort of like, overturn little stones about how I think about something that works that may not work the way it is, or to enter into a new field where I get to learn about, so like one thing that we're doing right now that I'm excited about to answer your question is whether social networks, so how people are interconnected with other people, whether they're represented in a cognitive map-like formation, and if so, how are they built? And so for me, this is like a new field that, has literature on rats and rodents and all sorts of things. And I'm learning a ton. And for me, that makes it a really interesting space to borrow tools that I don't typically use and I don't understand very little about, which I was, making arguments against this whole time. But to be able,
it's fun.
But it's fun. For me, it's fun, and it's a big learning curve. And to think about whether there's a application or a parallel for the way things are studied and have been studied for many, many years, and whether they apply to the complexities of the social world and where they might deviate. So the broad answer to your question is the things that bring me joy is when I get to study new things that I understand very little about, and there's a big learning curve.
That sounds exactly right to me. Well, and my whole career has been moving on from one field to the next because it gets boring, and in fact, getting the low hanging fruit in a new area is a much more fun thing to do. I mean, it helps if one can come up with like completely new areas rather than because Well, it's just because there's less competition in the new area. So you get a lot of low hanging fruit right away because no one else has been there. And then you move on once the place has been stripped and leave the legs for somebody else. So, I mean, I understand that. Well, I don't know if it is or not. It's a big space. There's a lot of dimensions out there.
It's interesting that you say that, Dave, because I was once talking to a famous researcher at Harvard who said everything in psychology and neuroscience has already been studied, and you and everybody else is just reconceiving it and thinking about it through a different lens.
Just reconceiving, like, isn't that the whole fun of it? Isn't it our whole job?
I'm guessing this was a senior researcher. I mean, I had this thing a long time ago that if you were able to ask just one question, if you were able to get just one fact about another person, what would be the most salient fact to get about the other person? And the answer I came up with was their age. Like that. If you're only going to get one thing, if you knew their age, that would give you more information than any other single fact about how they behave, what their interactions with you are going to be like, and so on. And I still think it. I still think if you had to pick one.
And can you say why?
Well, I mean, as I've gotten older, people that used to seem stupid don't seem so stupid anymore because now I'm the age they were when they were saying those stupid things, like that. And so both the hardware is evolving with age. Our human hardware evolves as we age. So especially when you're very young, that's a huge determining factor, brain development, physical development, all of that. But then even as you become a nominal adult, the difference between your 30s and your 50s is there's a lot of signal there. There's a lot of everybody marching down the same path. And we, especially, I don't know, in the United States, the Western world, have this illusion of individuality that we think, oh my God, I'm completely unique. And we have to have that bashed out of us the older we get and say, no, actually, we're kind of like 99% the same as everybody else, And we have this little one, so that's why age is the most important thing. That's what I thought. But as Michael was starting to say, yeah, I mean, our job is to reinvent everything every generation, taking it as it lays, which means we're sort of consolidating everything that's being fed into us, everything that's being fed in as received wisdom. That's all obvious if it happened before we were 18, and we just take it from there. So it's our job to keep recoding the little bits that are worth it, and cut loose all the stuff that was attached to it that didn't really need to be, if that makes any sense.
Yeah. Can I ask you guys a question? Am I allowed to ask you guys a question?
Sure.
You've actually done it a couple of times already. I've been very impressed. It's super fun. I really like how you've actually kind of chopped our legs out in a couple of places. It's really refreshing. Yeah. I'm loving this. But yes, please ask a question, please.
Okay, so my question is, do you think that the goal of the computing and AI world should be to ultimately mimic what humans can do? Or do you think that the goal is orthogonal to that?
You want to take a crack first, Michael?
There are many goals. If you're trying to build a system that's going to interact with people, which I think is a really good thing to do, is to build systems that help people accomplish the things that they want to accomplish. What
is something that doesn't interact with people?
That's a really good point that I think a lot of computer scientists forget. I think a lot of people, I was just in my new job, I was just hearing about one of my predecessors in this job who really was not interested in robots that interacted with people. It was too weird and messy. This person wanted to really study robots that were autonomous. They just went out and they did things. They were just independent agents. So I think the predominant attitude in the field is one of, well, wait, no, we want to make autonomous systems. Making systems that do what people tell them to do, that's boring because then all the control is in the people's minds. But I think there's a lot more of interest there. And so, yeah, I do think building systems to help people do what people want to do is a core goal, but not the only goal, apparently, for some people. Yeah. So if you're building systems like that, understanding human psychology and having some encoding of that in the systems is really important, because you're not going to work well with people if you don't have any clue about how people are, unless people are really simple, which we know is not the case. So given that they're complicated and quirky, giving the system some sense of those quirks is critical. On the other hand, if you're trying to build a, I don't know, an autopilot for an airplane, like doesn't seem that important to worry about those kinds of issues, and you can actually kind of reduce it to physics and do pretty well. So now I forgot what the question was, but do we think that's the ultimate goal? I think there's different ultimate goals. There's some systems that are really trying to do such and such, and some people who are just trying to understand the essence of what computation is. And then there's some people who are actually trying to build systems that are useful to people. And I think all those things are relevant.
So if we narrow the question, sorry. If we narrow the question to the one format, to the first prong, which is the systems that are built to engage with humans, should the goal be to mirror human flexibility?
I would take it in a slightly different direction, which would bear on your revised question, I think. And that, so should we try to be like people or just be like computing or just be like intelligence? How close is mimicry important? My answer in the big picture, which is what Computing Up is all about, is all roads lead to Rome. Humans are not the way they are just because of some quirky accident of evolutionary history on Earth. They are the way they are in large part because of computational necessities and computational complexities that you have to make simple approximations to, because that's the only game in town. You have so much time to make a reaction, you have to come up with it. So even if we tried to say, I'm going to make artificial intelligence using strips and symbol manipulation, and I'm going to write it in Lisp, and I'm going to have nothing to do with the brain, that's not going to work. And if you keep on developing it until it did work, you would discover it looks a lot like the brain. It has a lot of distributed stuff and so forth. So I think in the limit, it's a false dichotomy to talk about imitating humans versus going for intelligence via some other machine, because they're all going to meet up.
Convergent evolution.
Yeah. Like
that's
that. So,
so the goal, right. So then what Dave is saying is that the goal is not to mimic people, but it's going to happen anyway.
Yeah. Like that. The problem is, that's still a long ways away. And the kind of computer hardware that we're manufacturing now, which is still very centralized and deterministic, and all these things that people aren't, is that it's going to look bad for a while. But even going from symbolic manipulation by deterministic programming to deep learning and neural networks, where now it's all like numbers and floating point gushy stuff instead of Boolean algebra that's completely specific like that, that's already an example of what I'm talking about. That's already an example of how it's all going to come together in the end.
All right, so maybe we should give Oriel kind of a last word and kind of wrap it up.
What do you think?
Which may last word be?
That's what I'm asking. I don't know.
We cannot predict this.
I guess now that you asked these questions, now I feel like you're the host and you should probably figure out a way to end this thing.
Well, thank you, Michael and Dave. This has been fascinating.
It was so great that you asked us to come on. We rarely get a chance to be guests.
I don't have any last.
That's fair. Okay. Well, anyway, this is even cooler than I was expecting it to be. I really enjoyed your talk at RLDM, and you really did kind of push buttons. I don't know if that was intended or not, but you were kind of pushing buttons and kind of being a little irksome in a way that gets people thinking. And I am all in favor of getting people thinking. I think you did a great job of it. And today you did an even more direct job of that. So thank you.
It's easier with an audience of two.
Yeah, well, you made use of that. I was very impressed.
Well, thank you so much for having me. This is fun, and I can't wait to hear more Computing Up.
This was Computing Up. Thanks for listening.